get started with the presentation and demo. That's okay with you guys?
Mhm.
Or maybe wait a few more minutes for people to kind of come in.
No, sorry if I missed it in the very beginning, but your stuff is very sophisticated and detailed, way above my head. So can you maybe like 10 seconds like about your scientific background and how what you're doing fits into like the big picture, the small picture, kind of set up the context for us, please?
Yeah, definitely. Well, initially I was actually well, the plan was to kind of set up the context when I was kind of going over my kind of domain expert, and then I'll probably dive more into my background. But I guess it's like kind of that's almost like to the end, which is yeah, so it's kind of like flipping. But yeah, I can definitely share some now. Yeah, so I have so I'm currently a data scientist by trade, but I also do some like AI ML research. Some of my areas that I work on includes structured like tabular predictive modeling, NLP, time series forecasting, which is the project for SIBYL. SIBYL is the general purpose forecaster. And then now I'm also recently moving into uncertainty quantification or probabilistic prediction, which is what the MAUQ or MAUQ proposal is about. So yeah, that's kind of like a brief nutshell. But before that, I also had some experience in the crypto blockchain space. I was involved with a couple projects, including IOTA and then Fetch.ai. And then when I was at Fetch.ai, that's actually where I first met Robin, who's like a development relations engineer, and that's how I first met and interacted with SNet. But now, like, I'm now kind of fully transitioned to data science and AI, at least as a practitioner in that space. But at the same time, but now I'm hoping to kind of move back into the blockchain crypto domain application, but like kind of leveraging what I learned from AI and data science. Yeah. Cool. All right, awesome. So we have, I think we have 9 people here. Anyone have any other questions before I get started? If not, then I'll go ahead and start sharing my screen. All right. Cool. Are you guys able to see my screen? Awesome. Yeah, so for today, I have a I both have like a slide deck and also a demo that I'd like to share with you. And I'll go ahead and set this full screen. All right, hey everyone. Thank you so much for joining me in our break room. And so today I'll actually have three topics rolled into one. So it's a three-on-one presentation. So the first topic will be about SIBYL, which is the general purpose forecaster, and I'll be demoing our latest version. So SIBYL is a proposal from Deep Funding #2 that got awarded. So that is a project that we're currently working on, and then going to make it into fruition with the funding that we got. And then the second topic is about MAUQ. MAUQ, which stands for Model Agnostic Uncertainty Quantification. And then so this proposal is what we submitted in Deep Funding number 3. And then lastly, it will be quickly about my candidacy to the domain expert, so I can kind of give you a little bit of my background. But I also kind of like to discuss about kind of like the visions of decentralization as well as AI on more of a high level, and just kind of hear about what you guys think about it. So without further ado, let's go. So first topic, the SIBYL demo, which is version 0.3, and this is part of milestone M4. So first, just kind of give a overview of where we are in SIBYL. So SIBYL contains 2 API functions. First one is train, and second one is predict, although we now call it as forecast. So regarding the API function, we have implemented this part where user can input data into the train function. It outputs model parameters, and then of the trained model from SIBYL, and then the user can then input the trained parameter back in to make forecasts on future data set, and the forecast function will then output the forecast date times that the user wants, as well as the forecasted value from SIBYL. So the API part is completed, and currently we are hosting this on the AWS platform, including the API endpoint. Although we're currently working on trying to now deploy our API service into the SNet Marketplace platform. So now digging a little bit under the hood is the stacking architecture. So we have developed the statistical models, including seasonal naive, ARIMA, ETS. These are from M2, milestone 2, milestone 3. And right now we're currently implementing more advanced models, including machine learning and deep learning, such as LightGPS, LSTM, and NeuroProfit. And we have completed the meta model for weighted average, as well as another one called linear regression. And all of these it can illustrate during the demo. So all in all, I think we have about like 50% of the architecture implemented. So we're roughly done with like a third to 40% of SIBYL, since we still need to work on deploying and testing onto SNet, and then testing, and then the other half of the architecture. So that's kind of where we are now. So here a little bit more about like some of the updates from version 0.3 that we had. So now SIBYL can handle exogenous variables. Before, it can only do univariate time series. It also has linear regression meta model, while before it only has weighted average. We also added some preprocessors, such as simple imputer and min-max scaler. And we've also set up AWS servers for UAT and prod environments. So prod environment is for the for milestone M3, while our UAT environment is for milestone M4, which is version 0.3, which is what I'm planning to demo. All right, so now getting into the content of the demo. So the demo will be using a climate or atmosphere data set. So the goal is to forecast the temperature anomaly of the global land and ocean surface temperature, the average of those, using forcings from that are, whether it's like natural or like human or man-made. So the additional like details about the data set can be found in SIBYL design report. and the link is right here. So this use case has been inspired by SingularityNet's white paper about predictive analysis for climate change, user Granger analysis, Granger causality. Although like in our case, so I'm using a lot of similar data from this white paper, but more of a forecasting use case instead of causal inference. And here I'd like to give a big shout out to Matt and Nate from SNet and Cogito, respectively, for all of their support and assist for providing this use case. And I'm glad that both of them are also able to make it for this this presentation. Yeah, thanks guys. So a little bit more detail about the specific data sets. So the first one is temperature anomaly. So what is anomaly? Anomaly is kind of like where like the departure of the temperature from a long-term average, for example, 100 years ago. So in other words, the more the anomaly, like the more the current temperature kind of deviates from the historical trend and average. And then you can see from the graph here, this is from US NOAA about the temperature anomalies. And then you can see like during the industrial revolution, 19th century, it's actually a little bit, the anomaly is actually a little bit below like really long-term averages. But then you can kind of see more recently, 1980s to now, the temperature anomaly has really been picked up. And it's not just been positive, but it's been increasingly positive. So that's showing that there is like acceleration of the global land and ocean surface temperature happening. So the second data set is about climate forcing. And we got this from NASA, just so climate forcing is just the factors that may affect the Earth's land and ocean surface temperatures. Yep. Is there a question?
Oh, good.
Yeah. 1 second. Yeah. Okay. So, so in this data set, there are oops. Okay. So what I'll do is since I'm actually full screen, I'll go through like the presentation, like each part of the presentation, and then stop and then to kind of look at chat or if there's any Q&A, if that's good. Okay. So so for climate forcing, there are so for this data set, we're using 3 natural forcing, such as solar, stratosphere, and aerosol, like orbital forcing. For example, aerosol, these are from like volcanic ashes, so it's like naturally made. That while human-made or anthropogenic forcings include like releasing of greenhouse gas or change of like human land use, such as agriculture, deforestation, as well as like ozone, etc. So here's more details about like the forcing, about the different climate forcings. This is from NASA Scuba Institute of Space Studies. So what we did is we combined these 2 data sets. First one is temperature anomaly from NOAA, and then second one is the climate forcing from NASA. So we combine them together, and then because the climate forcing only has from the data set is only from 1850 to 2012, that is the date range that we had for the combined data set. So the temperature anomaly is the target column or target time series, is the is the value, is the what we want our SIBYL model to predict. And then while the other different climate forcings, whether it's like natural or man-made, these are the exogenous variables or different variables that can maybe be used to make the forecast. So we combine the data, this is what it looks like, and we will then feed this data into the SIBYL API service. And this is what the data is called. Any questions so far? Okay, so I'll continue. All right, so let's go ahead for the demo. All right, so first, get out of this. Am I sharing the screen still? Or not anymore?
Not anymore.
Okay. Have I been sharing the screen?
Kevin?
Have I been sharing the screen?
Yes,
You've been good until the last 10 seconds.
Oh, okay, perfect. All right. Cool. All right. So, okay, so I'm using AWS SageMaker Studio Lab. This is like very good to use like a free cloud environment, especially if you're a student. And then, so I've created an account, and this is the environment I'm using. So, so what happens is I first have this data set from, so here's the temperature anomaly, and here are the climate forcings in that data set. So I first put it in. I'm using Python and with a Jupyter notebook. I'm reading it in, looking at the data set. So, and then I split it into a train and test set. 80-20% train test. So this is the plot of the training set for the temperature anomaly. And now, next thing is, once I have the data, I clean it a little bit, I then feed the train data into the API and then feed it into the SIBYL API service version 0.3, just like that. So I have the, so right now, the API service is running on AWS, running 24/7. So it's kind of like listening for responses. So, so I just have the data, have the URL for it, run it, and then it first goes through the train API function. So going back to the deck, I have two functions. First is the train API function, and second is the predict. And then here, I input the training set into the API function. Output, I want to get the train model parameters. And so this is what I'm doing right here in the code. So I have the train API, I have the training data set, which is this. And then I train it, it outputs the model parameter, and then this is what it looks like here. So this is something that I already run, but I can run it again. So another thing before continuing is that right here, you can also specify what kind of model parameters you want to have, what combination of models, whether you want to include all the models or you want to have, like, specify specific models. But if you leave this parameter blank, which I presume most users would do, then SIBYL will use all the models, all the pre-processing, all the bells and whistles to go and automatically try to train the model. So it's like all hands on deck. So I'll go ahead and just run it. So it's currently running. Okay, so it's now at this point. Now is picking up. So it took about 9 to 10 seconds. That is when I fed the data into the SIBYL API service and got the response. And then this is the response, and then this is the model parameter. So what this is kind of like the serialized version of a combination of like the ensemble model that we have. But ultimately, what the user just needs is just this key value. And then in the forecast API, in this case, we're just using the test data, like the date times from the test data for the model to make prediction. So now is the second function, forecast API, where the user then passes in this model parameter, which is the output from the train API, and as well as the date times that the user wants to forecast, and then run it through the forecast API and gets the response. And here you can see that it was like 0.1 of a second or 0.15 seconds. Get a response, and this is the response. The response is what the user did to kind of make forecast, to forecast the data set. So this is the forecasted date times, and then these are the values. So finally, we can then say, okay, we have it in a stream. That's great, but now let's plot it to see what it actually looks like. So here is the training data set again. This is what the user passed into the train API to train the model. Then this is the output from the forecast API using the train model from the train API. So then, and then this is what it looks like when I put it together. So here, this is the original data set. And then this is the train, and then this is the what SIBYL forecasted. And then finally, here is because actually the original data set has from
It has served me well throughout my entire life.
From 1850.
But first, I got to tell you a little story. When I joined the Navy, a lot of you guys don't know this, but
You should mute him because it doesn't sound like.
Because the Navy found I had a 7-centimeter pericardial cyst on my heart. It was
Okay.
All right.
Great. Awesome. So in the original data set, you can see it's from 1850 to 2012, and then I split the data set 80%, 20%. So this has been trained right here, and I've been using this part to make forecast. So here you can kind of see how the SIBYL forecast performed compared to the original data set. So so the red is the SIBYL forecast, and then all the blue is the entire data set. And then it made forecasts from like 1980s all the way to 2012. So you can see that it actually caught the trend here. It went up, but it maybe went up a little bit too much right here. So this is kind of like the first pass, and I'm using the default settings from SIBYL. well, we can kind of like play around, because that's the goal. For SIBYL is it can be used as like an experimental tool, so you can pass in like certain parameters of what data, like what type of models you want to train, and then it's like commands, and then you just pass it in to the SIBYL API service, and SIBYL will do all the work for you. So let's do another example. So this time, I will actually want to pass in a custom model request. So behind the scene, this is what the default model looks like. Well, let's say that we want to try all the base model except for one of the models, which is ARIMA, because we think that ARIMA is probably one of the models that might be dragging the entire SIBYL forecast down. So we can say, okay, let's just have all the base models except for ARIMA. So what we do then is we just comment this out. So then when we pass it in again with this model request, we're telling SIBYL, okay, you can consider all of these models, but remove ARIMA. So we can go ahead, and then before I run it again, let's kind of take a look at, okay. So it's, you can see in the test set, it's around like 1.2. That's how much it forecast right here. So let's remove all ARIMA and see what happens. And then we'll just run it through the entire thing again. Start, I don't know, run all cells. Okay, so now it's running through again, going through both the train API function and also the test. And then this time it actually went faster because ARIMA actually took quite a bit of time to do because it has to do a lot of the, since the ARIMA has to like look at all the different hyperparameters for like auto regression, moving average, and then differencing. So it got the model, we passed in the model, we forecasted, and now we can take a look at the results. Okay, so the forecast here, the peak actually hits 1.2. So before, with ARIMA, the peak here is actually a little bit below. So what you can see here is, at least based on this data set, auto ARIMA, that base model, is actually positively contributing to the model results. And you can use SIBYL as a way to kind of play around and make these type of inferences and predictions and going back and forth. Any questions so far? All right. And then I could do like one last one before we conclude the demo. So okay, let's say that, okay, so we're using the linear regression meta model. How about let's try using weighted average meta model and see what happens. So weighted average meta model is like our first implementation of a meta model before we move into a more advanced one, which is the linear regression. So here I can then specify SIBYL, okay, just do weighted average, don't do linear regression, to kind of ensemble these base model results. So go ahead and do that, and then run it again and see what the results are. So it ran through. Okay, it stopped. So yeah, you can see it doesn't look that good right here. Instead of going upwards like this, it actually kind of just like flatlines. So it's kind of like a naive model where it kind of stops at last train and just like flatlines. So that's kind of like what's happening. So you can then see how linear regression is a much better weighted. Linear regression is a much better meta model than weighted average. So yeah, so that's the demo for the current version 0.3 for SIBYL. You guys have any questions before I move back to the slides?
Sounds
Alright.
interesting.
Thank you. Thanks. Cool. Sounds good. All right, so I'll go back to the slides again.
Actually, I have a quick question.
Yeah.
So you showed overshooting using some combinations.
Yep.
And with the weighted average undershooting.
Yep.
Did you ever find something that actually came really close to what actually happened?
Yeah, that's a good question. So
I
actually,
realize it's a platform that allows you to experiment with using different combinations of models, different ensembles.
yes.
I'm just curious. I mean, it seems like if you should be able to probably overfit that way, but it'd be interesting to see.
Yeah, so I can answer your question while going back to the slides. So yeah, exactly. So going back to the presenter view. So yeah, so first, you're right. There still need some like room for improvements. So the model overconfidence and also the underconfidence, and that's why it's still kind of underdeveloped. We want to continue to first kind of build out all the capabilities for SIBYL. Like for example, we just mostly have the like statistical data. Well, hopefully, if we have more advanced data, advanced models like GBM and LSTM, that's more non-parametric, and then use those, and then maybe kind of figure out like automatically how to hyperparameter to them. Then we can maybe figure out ways we can then try to fit it better. So, and then the second,
Fair enough.
Yeah, so we're still developing the capabilities, and with the hope that we can make a much better and better forecast that's closer to reality. And so, and then for this case, this is more just kind of demoing kind of like how it works. But of course, the next steps would be kind of doing a bunch of more of these type of testing, and then try out the different like parameters to see what models fits with what type of data sets as well. And then not just building out more base models, but also like different types of pre-processing methods as well automatically. So we can maybe like figure out ways if we like transform the data into this and this ways, or even doing like some automatic feature engineering, whether like manipulation like from the data side can actually then lead to better model forecast as well. And of course, another next step will be building like a front-end UI. Maybe we'll start out building it on the SNAP website itself, so then user can just simply upload the data that they want to forecast, to train forecasts on, and then SIBYL will take care of the rest. So with that said, we definitely are looking for more like alpha testers, users, so we can further look at kind of like your applications and your use cases. For example, what we did with Matt and Nate, and how we came up together to use this climate data as a way to test and demo SIBYL, and we definitely want to see, will invite more of you from different domains, like for example, like energy, crypto, finance, markets, or others, to also hope we can actually experiment and test and then continue to improve on SIBYL as well. So with that note, so that is SIBYL. So any final questions on SIBYL before I move on to MAUQ? All right. If not, then I'll go to MAUQ proposal, which is our proposal in Deep Funding 3. So I did do a like a pitch deck on a presentation during IDFS, and I was wondering whether and a lot of my slides is kind of like using it from that pitch deck in IDFS. So I was wondering whether I should go over MAUQ again, or should I kind of like run through it and like kind of give a summary about it.
Kevin, not understanding this subject area much, I cannot tell which parts are very standard to this field compared to which ones are your innovations. Could you maybe speak to that?
Yeah, definitely. And I think one of the reasons why I have all these presentations together is so I can then highlight how the different AI services like SIBYL and MAUQ kind of interact with each other, how they can help each other, augment each other. And then that is actually what I'll get into. If that's what you're asking.
Well, like you showed the diagram and the flow of steps, and I cannot say like, okay, this is like what everybody always does, and compared to, okay, here's Kevin's great idea. This is like, we should all be like wow about. That's all I'm saying. Tell us what to be wow about.
All right. I'll get into that part. First, we need to have a little bit of build up, if that's okay. All right, so first is kind of like what is MAUQ? And MAUQ is model agnostic uncertainty quantification that turns your predictions into a more of a probabilistic prediction. So the goal is that, like SIBYL, MAUQ is also something that is hopefully model agnostic, data agnostic, and also it can work with different problem types such as regression and classification, and it will also be automated. And then it uses conformal prediction, which is one of the up and coming areas in the AI space, and where our plan is to wrap it up and provide that as an AI service. And then MAUQ has just one function, which turns your data with model prediction to actual values and use that to make uncertainty quantifications. So I know a lot of what I said is very technical, but this is kind of like how it all kind of comes together. So my goal is to make MAUQ to be able to interact with other AI services as well as applications themselves. Same with SIBYL. SIBYL can interact with other AI services as well as other applications as well. Like SIBYL also uses other AI services, like for example, onboard neural profit. So it takes in that service as another base model and then use that, its output, to then use it to combine. So we're kind of trying to chain all of these AI applications together so they can actually upgrade each other's capabilities instead of developing these AI services in isolation, like different islands. So we want to build AI services like SIBYL and MAUQ. Both they can be in isolation, standalone, but they can also connect to each other like building blocks. So it's intelligent AI, or like AI can enhance other AI and then make a chain of intelligent AI for even better, to make applications even better. Case in point. So I think I showed you this, right? So this is what the demo results look like. So you have the SIBYL output like right here. Here is the original output. And then we talked about how we still need to continue working on improving the model results for SIBYL. Well, one thing that can help for us to figure out how good is the model is using MAUQ. And we can use MAUQ to then say, okay, how good or how confident is the model prediction from SIBYL? And the way MAUQ can figure that out is to create these type of prediction interval. So it's like we have an upper, so we have the point prediction from SIBYL, but MAUQ could then produce upper and lower bounds of this prediction on a given confidence level, let's say 90%. So then you have this prediction, and then you have the upper and lower bounds. And then you can take a look at the upper and lower bounds, which forms prediction interval, and say, okay, how confident is this model? If the interval width, like the space between the two interval, if they are very wide, that means it's like a 90%. It falls in between these two wide area of interval. And that tells you the model is not very confident because it needs to have a very huge width in order to be 90% confident that the future data point falls in between those areas. However, if the prediction interval is more narrow, like for example, like right here, you can then use that to then say, okay, the model prediction is actually very confident or has high certainty of the prediction or the forecast it is doing. So uncertainty quantification or these prediction interval could be very good for like post-processing analysis, kind of similar to why interpretable or explainable machine learning is. Because if you have certain forecasts or models that produce a certain forecast, it seems like you can trust them more and you're more likely to take heed of it. But if you model that produces uncertain forecasts, for example, it has higher uncertainty interval, then you should be more likely to kind of disregard it. Or you can further dig into it and then maybe to see why it's being so uncertain. And then maybe you can kind of use that information and then maybe take a look back into the data and then kind of see that maybe the data is maybe too noisy, too biased, etc. And then maybe it's actually not best suited for model prediction in general. So this is an example of how you can have two AI services, model and like SIBYL, which we're currently building now, and MAUQ, which is what we're proposing to actually augment each other right here. So I can go even like a step further. So our greater SNet mission is to actually try to make decentralized AI, which is, I think, our collective vision, a reality. And how we're trying, our approach is to try to build these core infrastructural AI services onto the SingularityNET platform. And that's what we're currently starting to do right now. First, with SIBYL, that we showed like the demo for version 0.3 currently on AWS API service, and we're hoping to actually now deploy to the SNet marketplace. And then alongside with SIBYL, we also have onboard neural, which is an AI service that feeds into SIBYL. And we can even add an existing AI forecasting service by SNet. It's called SNet Time Series Forecasting, and then feed that into SIBYL as well. Now we can also add in MAUQ, which is MAUQ, to do the probabilistic forecasting, and then we provide that to SIBYL. So SIBYL not only does the point forecast, but it also does the probabilistic forecasting as well with these intervals. And what's really great about this is that they can feed with each other, but they don't necessarily have to depend on each other, because MAUQ itself, since it's a standalone AI service, could then work with like other like AI services or use cases or applications, as well as SIBYL as well. It may or may not use MAUQ. So you can see how you have all these different AI services that is developing a web of AIs, and they can like help each other. They can enhance each other's capabilities, but they can also work with direct applications end to end as well. And I think that this combination of different AIs is what makes it really powerful. And like our approach is like we're trying to build it, and then starting with these services, which are domain agnostic, model, like data agnostic, etc. So we can be able to integrate that with a vast varieties of different AI services, applications, and use cases. For example, with the climate use case we just mentioned before, but it doesn't just have to be climate. So yeah, that is MAUQ. You guys have any questions there? Is that a wow factor enough? All right, so I'll finally kind of get into the domain expert, and then hopefully that can kind of just kind of put these all together, more of like a high level overview. And then, well, before doing, well, here's the founding amount that we have, and then here's our team for MAUQ MAUQ, and a lot of our team members are also from SIBYL as well. So we have a lot of implementation experience from SIBYL, and we're going to bring to MAUQ, as well as kind of establishing the API, AWS, the development lifecycle using like on GitHub, etc. So all that experience we're having with SIBYL, we will hope we can transfer and make it more efficient when we're implementing MAUQ for Deep Funding 3. So yeah, definitely vote if you haven't already. So MAUQ is proposal 3 is under new projects, and then we actually have another project. This is also with Matt from SNet, and then this is modeling soil health indicators at scale for agriculture and climate. So it's a somewhat related, a bit related to our use case for like temperature anomaly. And this is a proposal under the ideation category. So there's 2 proposals for Deep Funding 3. So definitely vote, and vote in general. So I'll quickly go through the domain expert, and it's just a way to better like kind of introduce myself, my background a little bit more. So I am applying to be a domain expert for the SCDAO Task Force, more hopefully to bring areas of AI and data science, and especially as a practitioner. So yeah, currently data science. I also do some AI research, also open source on the side, development on the side. I have a mix of both blockchain AI experience. Currently AI practitioner now, but I used to be in the blockchain space full time a few years ago before like I transitioned to do more AI work. And now hopefully I'm trying to merge those two worlds together. I also have a corporate startup experience. Used to work for a bank, investment fund, before moving more into like the crypto blockchain space. And then here are some of my AI and ML experience right here. So here's my view on decentralization, or my vision on decentralization. And then this is coming from someone who used to be in the blockchain crypto space, looking in, well, I mean, within blockchain crypto space, but now I'm more in the like AI data science space, looking out towards like what's going on like decentralization in blockchain. So that's kind of like the lens that I'm looking at. So I do see we will get this, like decentralization is kind of like exercise where it's hard, like to master. It's going to be a lot of pain. You'll be hurt, sore a lot, but I think that that's something that we'll master at some point and achieve like some kind of a slope of enlightenment. And the reason why is I think that decentralization is kind of like it's like a double-edged sword. On one hand, it really empowers the masses and then lowers the barrier to entry. And I think a no better example of that is what happening in like, like crypto blockchain. It's like what happening in more like developing countries where their like financial institutions are much less like mature, or their governments and their like monetary system much more volatile, and they have to deal with rampant inflation. So then they can then actually see the different types of crypto like Bitcoin and Ethereum as actually something that's more trusted and reliable and easier to use, especially with cross payments, because if you have like a wallet address and you have access to internet, it doesn't there's no like national boundaries. You can just go from one wallet to another wallet and make payments regardless of what country that you're from. So I think that is very, very powerful, and and then this entire system is decentralized. So it's kind of it's like diversification across different countries in order to kind of prop up this protocol system. So if one like country or area is try to tackle it, there's other countries or people in other countries or areas can still continue to run the protocol. And I think that's the great strength of like blockchain crypto. And I think that's the plus, that's the benefit. But then on the other side, because it is appealing to the masses, and then there's like a lower barrier to entry, it can also it can also invite more like malicious actors whose like incentives don't often like align with those in the protocol. So so like exploits, hacks, etc. But at the same time, but also because it's a decentralized system, there isn't really like by default there shouldn't really be like big authority figures that kind of call the shots, where the bull stops with them. So because of that, there could be also like a lot of like potential for like kind of like factionalism within decentralization that can kind of stifle like maybe like productive growth. Actually, like maybe one example, maybe I think an old example right now is like what happened with Bitcoin, with the hard forks that's happening, Bitcoin, so like Bitcoin Cash, etc. So, and so there is a so I think there is a trade-off from like Vitalik talking about the blockchain trilemma. Is like if you want to do this, if you want to do decentralization and scalability, you'll then have to sacrifice, and it'll have to be at the expense of scalability, and vice versa. And I think that's kind of what I'm seeing with like L2 protocols, which I might be wrong, because I think my like knowledge base for like blockchain crypto could be dated, but is it like L2 is maybe like trying to make it more scalable, but at the same time maybe like sacrificing the decentralization a little bit, because doing more stuff like that's taking place like off chain, for example. So I'm sure there's kind of like a so it's like kind of like a pull, like tug ropes between like one hand is like decentralization and scalability, and the other hand is like scalability. I mean, decentralization and security. The other hand is scalability and user adoption. And I think that is one of the reasons why a lot of like tech hype right now is around kind of like narrow centralized AI systems such as ChatGPT, GPT-4, by like big monolithic that have like companies like OpenAI, Google. They kind of hoard a lot of the computing resources in order to create these amazing AI models and products that can be used widely around the masses, is because they don't have to deal with this this pesky thing called decentralization, because they're like on singular company, and then so forth. And then they have like a clear hierarchy, and they have the CEO. The CEO calls the shots of like what the companies should do, not to do, and so forth. But so my view is, I don't think that like blockchain, crypto, permissionless systems will be more scalable than, let's say, centralized systems like Visa, because in order to do so, they're like the weakest link in like blockchain protocols have to be like faster than Visa as well, because it's the weakest link that kind of slows down the system, I guess. But that doesn't mean that there won't be any like economic viabilities or massive like adoption that can be found in the blockchain crypto system. Like for example, like as mentioned before, like cross payment systems between country A and country B, especially in countries outside of like developed countries and so forth. So I think that we'll have like a kind of a maturation process towards decentralization, where we can have like a steady decentralization process that can also be like productive as well. But I think that that is going to be a process, and there will be ups and downs in order to get there. I definitely said quite a bit. I just want to see anyone else have like thoughts about this. Yeah, you're welcome to unmute. If not, then I'll go on to my view on my vision on AI.
Again, just to say, I find your stuff very interesting, a bit above my head, so I'm gonna do more reading offline and maybe ping you directly with questions. But I think we're in silence, not due to lack of interest, but maybe a little overwhelmed.
Yeah, I totally understand this. I know there's a lot of there's a lot of pack of information. But I'm definitely happy to go like anyone who's further like interested to kind of go like back and forth and so on. And, yeah. But yeah, so I mean, we don't have to talk like now. We can always talk offline or like the next, next session and so forth, and then discuss. Yeah.
In that case, since you're going to talk about your outlook afterwards, could you fold back that picture you have where you are bringing in the course of your, participating in the rounds of deep funding, filling out the larger canvas? Maybe if you can tie your, big outlook to how you're building up those components, that would maybe make it all hang together.
Yeah, and hopefully I can maybe like wrap it up on this presentation with my outlook or vision on AI, since that's ultimately what I'm hoping that I could bring to the table for the task force, as that's like my currently I think my area of specialization, at least at the moment. And I think it does also kind of mirror with my my view on decentralization. I do think that for AI, just kind of like the payment systems in blockchain that's been like decentralized. I think AI, there will also be some kind of impetus or push to kind of like try to decentralize AI as well, which is what Ben, SNET, like you guys are doing with this platform, and providing the grants to Deep Funding to help like projects like ours to kind of implement these services, which is something that I'm always like forever grateful for. And I think that this it's like there will be this like grassroots push to actually build greater AI systems from the bottom up, as opposed to like kind of like top-down AI, like as mentioned before, like you have big LM models from big companies, and then they're kind of like calling, like you have like these few AI researchers kind of like calling the shots, and so forth, and then they're the ones who's kind of always on the hot seat, like in Congress or like different parliaments, like EU's like figuring out what to do, whether to ban parts of AI or regulate it, and then so they're the ones who's trying to like maybe call the shots and also take the heat on it for like the direction of AI. But I think there's some pushback for that, and I think the first pushbacks is in open source systems.
Just a real quick question.
Yeah.
You mean the no free lunch theorem, right?
Oh, okay. So that's another rabbit hole. Yeah. No, I guess
I'm reading your slide and I just saw that.
Okay, I guess there's two levels of decentralization. The first one is who's doing the implementation of AI. The second one is what coverage does like specific AI models have in like what use cases for the world. So right now I'm kind of talking about the first one, like who's like making AI.
Right.
And I think there will be more of like a bottom up kind of like movement, and And then I think the first step is kind of like what you're seeing with open source large language models, like Llama, for example. And then like all the kind of development that's happening in open source for like large language model, and how like they're developing so rapidly that they're actually setting off alarm bells in big companies like Google. I think that's definitely the first part, like the power of open source and spreading models and then making it public, and then other people kind of further develop it. I think that's the first step. The second step is if you have more like an open way of developing models, but also paired up with a open way of kind of making monetizing it. So and then not just like the implementers implementing the models, like getting like being able to monetize it, but also like the models themselves can then kind of freely seek out other models and then perform economic transactions with each other to kind of prove their like viability, that their need, their value economically. And I think that this is a way where you can have decentralized AI can then kind of merge with like a decentralized payment systems like blockchain crypto. So that I think that's the first part. And then the second part is maybe the reason why we'll probably see like a bunch of AI models is kind of going back to the no free lunch theorem, which is okay, so yeah, no free lunch theorem is that so this is kind of like my view, is that if you look at a bunch of like real world data sets, especially in time series, like the messiness, the bias, noise, and all that, like the data set is like way too heterogeneous, or too varied for like a singular model to kind of fit or like overfit on them and then be able to kind of generalize. I think a more probable approach could be you still have these like narrow AIs that kind of specialize on these like clusters of data points that represents some like real world like domain use cases, and then like fit on those models, and then maybe then further kind of interact with each other to perform like, and then economic transactions with each other. For example, so it's kind of like you have these models kind of like companies or like countries, they kind of specialize in like one product or service or like economic like goodie, and then they kind of trade with each other using their comparative advantage. So I think that these AIs like with specializing their given domain or data sets could then specialize in those areas and then be able to transact with other AIs and then try to hopefully in a mutually beneficial manner to then kind of trade with each other. And then one AI could then like outsource some like intelligence need from another AI instead of that AI trying to learn everything by itself. And I think that's what like big companies are trying to do, have AIs that can do multimodal, like do everything, which takes a lot of like time, a lot of like models to compute, etc. But instead, you can have these different AIs kind of specialize in areas and then like kind of trade with each other, and then use decentralized system like blockchain crypto to facilitate those transactions. And I think that so that is kind of like how it becomes from narrow AI that's like isolated to become more like swarm or narrow, like a more of a swarm economically incentivized AI. And that's actually kind of like what we're trying to do with just starting off with like SIBYL and MAUQ. These are just like the starting pieces of like AIs actually acting with each other in a more of like a economic sense, and actually benefiting each other. But of course, these are right now, these are like kind of static, and then we're kind of like linking them up like jobs, like scheduling jobs and then kicking it off. So that's kind of like this. But I think maybe in the near future, and I think there may be some teams at SNES kind of working about it, where maybe these services could kind of automatically find each other and then perform these transactions. And I think that this interactions with these different AI, like specialized AI, and then they trade with each other, and then they form like these linkages with each other economically, could then finally coalesce or kind of synthesize into something greater, which may ultimately emerge into something like AGI or ASI, something like that. So that's kind of like my vision. I might be that's kind of my view. I might be very maybe not maybe grounded but not grounded, but that's kind of like my vision. Happy to kind of discuss with anyone further who's kind of interested in discussing about that. Cool. I think it's been a lot, so I'm glad that for those who are still here, thank you so much. So here's my email, here's my Discord, and I hope you guys have a great rest of your day. And I can like continue to chat with you guys, whoever is still interested, Q&A. But other than that, thank you guys.